Hello everyone and welcome to Ksoft Labs Institute. If you're looking to kickstart your journey into the world of software development, then you are in exactly the right place. Today, we're laying down a really crucial foundation. We're going to dive into the Java programming language, an incredibly powerful tool that's used pretty much everywhere, from big web applications to the apps on your phone. So let's get right into it.
So here's our game plan for today. We're going to start with what I like to call Java's secret sauce. What makes it so incredibly popular and resilient? Then we'll roll up our sleeves and get into the absolute fundamentals, variables, and data. After that, we'll see how to make our programs a little bit smarter by teaching them how to make decisions. And finally, and this is a big one, I'll walk you through setting up your own programming environment, your digital workshop, if you will, so you can start coding immediately.
Okay, so first things first. What is it about Java that's kept it so relevant for decades? Well, it all comes down to its core philosophy, this powerful idea, write once, run anywhere. Let's really unpack what that means for you as a developer. Just think about this for a second. Back in the day, if you wrote a program for a Windows computer, it just wouldn't work on a Mac. You'd have to completely rewrite it for every different system. As you can imagine, this was a massive headache for developers. But then Java came along with this really elegant solution to this exact problem. So how did they pull off this magic trick? Well, the answer is a concept called platform independence. And the hero of this whole story is something called the Java Virtual Machine, or JVM for short. Here's how it works. When you write your Java code, it gets compiled into a special intermediate format called bytecode. Now, this bytecode isn't for Windows or for Mac. It's a kind of universal language that only the JVM understands. So the JVM on your Windows machine takes that bytecode and translates it for Windows. The JVM on a Mac takes the exact same bytecode and translates it for macOS. That JVM acts as a middleman, a universal translator. It's the key to everything. You write your code just once, and it can run on any machine that has a JVM installed. Pretty cool, right?
All right, now that we understand the why behind Java, let's get into the how. We're moving on to the fundamental building blocks of the language. You can think of this section like we're learning the alphabet and the basic vocabulary of a new language. This is where we learn to actually speak Java.
The most basic concept you've got to grasp is the variable. Really, it's just a named spot in the computer's memory that you've set aside to hold some information. I love the analogy on the slide. It's just a labeled box. You can create a box, stick a label on it that says user score, and then you can put a number inside. Now here's the crucial rule in Java. You have to say what kind of information the box is designed to hold from the very beginning. This is a concept known as static typing, and it's a huge help because it stops you from, say, trying to stuff a word into a box that was designed for numbers. It helps us avoid a ton of common errors.
And this table here shows the most common types of boxes you'll be using. These are called primitive data types. So for a whole number, like a score in a game, you use an int. For numbers that have a decimal point, like a price, you'll use a double. For simple yes or no, true or false values, maybe to check if a user is logged in, you use Boolean. And for just a single character, like a grade on a test, you use char. And notice it uses single quotes. This pattern right here, the type, then the name, an equal sign, the value, and a semicolon at the end, you're going to be typing that constantly, so get used to it.
Let's see how this works in practice. As this code snippet shows, you can do this in 2 steps. First is declaration. That line, int user age, is basically you telling the computer, hey, I need a box that can hold a whole number. Please label it user age for me. At that moment, the box is created, but it's empty. The second step is initialization. The line user age equals 25 is you actually putting the number 25 inside that box. Of course, as programmers, we like to be efficient, so most of the time you'll just do both steps at once, just like that last example. String username equals Ksoft Labs. Boom! One line, clean and simple, we've created the box and filled it.
So we have our variables, our boxes, and they're full of data. What's next? Well, now we need to actually do stuff with that data. And that's where operators come in. If variables are the nouns of our programming language, then operators are definitely the verbs. They're the symbols that let us perform actions, add things, compare things, and generally manipulate our data in useful ways.
Let's start with the easy ones, the arithmetic operators you already know from math class. You've got plus for addition, minus for subtraction, the asterisk for multiplication, and the / for division. Now, the one that might be new to you is the percent sign, which is the modulo operator. All it does is give you the remainder after a division. So, 10 modulo 3 would be 1, because 3 goes into 10 3 times with 1 left over. This is super handy for things like checking if a number is even or odd. And in the example, int result equals 10 plus 5, the computer does the math and stores the answer, 15, in our variable called result. Simple as that.
Okay, this next part is where our programs start to get really intelligent. Up until now, any code we'd write would just run straight from top to bottom, one line after another. But what if we want our program to make choices, to do one thing if some condition is true, but do something completely different if it's false? This is called controlling the program flow, and we do it using things called conditionals.
In Java, we have two main tools for making these kinds of decisions, the if-else statement and the switch statement. And this slide is a great guide for when to use which one. The if-else statement is your flexible, all-purpose tool. You can use it to check for really complex conditions, like is the score greater than 80 but also less than 90? The switch statement, on the other hand, is more specialized. It's perfect for when you have a single variable and you want to check if it matches one of several specific, exact values, like checking if a variable for the day of the week is equal to Monday or Tuesday or Wednesday.
Okay, let's look at an if-else statement in action. We start with a variable, int student score equals 85. Then comes the decision point, the condition. If student score greater than or equal to 60. The program asks itself, is 85 greater than or equal to 60? Well, yes, that's true. Since the condition is true, the program runs the code inside the first set of curly braces, and it prints pass to the screen. And because it did that, it completely skips over the else block. Now, what if the score was, say, 50? Well, then the condition would be false, so the program would skip the if block and jump straight to the code inside the else block, printing fail. See how it chooses a path?
And now let's check out this switch statement. We start with char grade equals b. Then we have switch grade. What the program does is it takes the value inside grade, which is b, and it goes down the list looking for a matching case. It checks case A. Nope, that's not a match. It checks case B. Aha, we have a match. So it executes the code for that case. System.out.println, good job. Then it hits this really important word, break. That tells the program, okay, we're done here, exit the switch block. If we forgot that break, the code would just keep on going and run the code for the next case too, which is usually not what we want. Finally, that default case at the bottom is a safety net. It runs if none of the other cases match.
We've covered a ton of theory. Now it's time to shift gears and get practical. To actually write and run Java code, you need to set up a proper workshop on your computer. We call this your development environment, and we're going to walk through setting it up right now.
The very first thing you need is the Java Development Kit, or JDK. This is the core set of tools from Oracle that lets you compile your Java code into that byte code we talked about earlier. As the slide says, you'll just head to the official Oracle website, find the JDK for your operating system, download it, and run the installer. And I really can't stress this enough. If you get stuck, always check the official installation guide. It is the ultimate source of truth.
Now listen up, because this is a pro tip that will save you so much frustration later on. After you install the JDK, you have to tell your computer where you put it. You do this by setting what's called an environment variable, specifically one called JVA_home. Think of it like a giant signpost on your computer. When other tools need to find Java, they just look for this signpost. This is especially important on Windows. Seriously, don't skip this step.
Okay, once the JDK is all set up, you need a place to actually write your code. Now, you could just use a simple text editor, but it's way better to use what we call an Integrated Development Environment, or IDE. We recommend starting with Eclipse. An IDE is like a super-powered workbench for coders. It gives you an advanced text editor, a way to compile your code, and tools to hunt down and fix bugs, all in one place. Just follow the steps on this slide to get it installed, and you'll be good to go.
And just like that, you now have a fully functional Java development setup on your computer, and you've got a solid handle on the absolute core concepts of the language. Before we wrap up, let's do a quick review of the essential tools that you've added to your programming toolkit today.
So let's recap what's in your new toolkit. You understand Java superpower, that write once, run anywhere ability thanks to the JVM. You know how to create variables to store all kinds of different data. You know how to use operators to actually perform actions with that data. You can now write intelligent code that makes decisions using if, else, and switch. And most importantly, your digital workshop is set up and ready to go. You literally have everything you need to start building real programs right now.
So we'll end on this thought. You know, programming isn't just about learning syntax and logic. It's a creative medium. You've just learned the fundamental grammar of a powerful new language. The real question is, what are you going to build with it? What problems are you going to solve? What story are you going to tell? Your journey officially starts now. Thank you so much for joining us at Ksoft Labs Institute. Happy coding!